Hi, I am Hossein Hariri, and this is a video from Zal Yafte Academy, www.zalacademies.org. Check the description of this video before starting to watch it. If you are using a computer, the description is at the bottom. Click Show More to see more of the description. If you are using a tablet or a mobile, click on the little arrow at the bottom right to view the description at the bottom or on the right of the video. The description tells you where to find the statement of a problem and the meaning of a problem ID. If you click on the link for a problem given in the description, the video will fast forward to play the solution of that problem. When a problem takes more than one slide, you can see a phrase in the parentheses in front of the problem ID that says, "See the next slide for more." The last slide for such a problem has the word "continued" in short form after the problem ID. If the solution of a problem needs explanation, it has been added before the solution is presented. Otherwise, the slides for a problem will be played after a start sound. The transition of each slide normally takes 12 seconds. The problems in this set involve performing material balance on chemical processes that involve multiple units. Solution of these problems can sometimes become complicated. That is why we have named them complex systems. Material balance has been discussed in detail in 2 lectures, 3 videos with titles Systems and Flowchart, Mass Balance, and Guidelines, and 3 lecture notes that are all posted on the page for topic 3. The materials mentioned explain how the law of conservation of mass may be applied to chemical processes involving single units as well as multiple units. In this problem, we have 3 products, E, P, and B. In each of these products, we may have components ethane, propane, and butane. When we want to label mole fraction of a component in a stream, we should use 2 identifiers like Y sub E, C2. There are different ways of using these 2 identifiers. One is as shown, where both appear in the subscript. Alternatively, we can show C2 as a superscript and E as a subscript. As we move on to more problems with multiple units, the flowcharts become more involved. To assist you, a PowerPoint file has been posted on the page for topic 3 under the section of problems. A number of blank and labeled flowcharts are included in this PowerPoint file. Blank flowcharts may be edited for your convenience. In this problem and many others, a table for the degree of freedom analysis is normally set up. Blank tables are also provided in another file on the page for topic 3 under the section of problems. The table in this problem is shown, which has 5 columns. The second column shows the unknowns. The third column shows the number of balanced equations that we can write. Normally, this is the same as the number of components. The fourth column shows the number of equations other than balanced equations. These may be given in the problem, like process specification. In the textbook on pages 99 to 100, multiple categories are named for this type of equation, namely energy balance, process specification, physical properties and laws, physical constraints, and stoichiometric relations. Refer to these pages for more explanation. Also, bases can be counted as an equation of this type. In the fifth column, DOF or DF is shown, which is the difference between the number of unknowns and the number of equations. When DF or DOF is 0, we can solve the equations for the system on a row. Once the equations for a system are solved, some of the unknowns for the other systems also become known. In the new situation, the DF changes, which will enable us to try to solve other systems for which DF has become 0. Also note that we do not have to solve all the equations. We just solve the ones needed to answer the questions in the problem. That is why a DOF table is a roadmap for the solution of problems involving multiple units. you.